Hi, it's Gadget UK here again, back for the final part here of the Nomad. So it's just tying up some loose ends. You saw we replaced the screen in the previous part there, and yeah, I chipped the glass down the corner and it looked a mess. So I ordered some 3 new screen protectors from Console 5, and I'll have a go at fitting and replacing one of those. But I'm going to swap out the remaining capacitors here. So the ones with a little red dot are the ones I did on part 1 and part 2. The ones on this board, I did all of them, but nevertheless there are quite a few caps on here that still need replacing, and whilst this works perfectly, because of the volume that had leaks on here, I wouldn't want to leave the other ones on there. I would just replace the other ones as well. So I'll show you a couple of different techniques. We'll do the cutting into the can, because that can work if you've not got hot air. I'll try and show you how you can heat one side with a bit of solder braid, lift it a little bit and heat the other side, but there is a risk, and I'll explain, I'll sort of kind of quantify the risks as I do each one of those, and then we'll just use hot air to remove the majority of them, which is the best way of doing it, and I'll show you fitting 1 or 2 of these as well. At the same time, we'll also cover the Master System Support mod, because I think as default they've not connected one of the connections from the ASIC on this board here. I forget, I think it's either pin 44 or 45, and it's the M3 pin, and that pin, I think when you connect ground to it, kind of enables allows Master System support, and I think Sega intentionally did that. I don't think that's a mistake. They intentionally did not connect that, because the way that, well, back in the day, the way that you would connect a Master System cart up to this is via the power base adapter or whatever. It's like a big bulky thing, a bit like the 32X, not quite as big, that plugs into your Mega Drive, that then allows you, to pass through Master System games. And I don't think there are any active components in there as far as I understand, or very little in the way of active components, but nevertheless it was a big piece of kit. So I think Sega perhaps thought, we don't really want people plugging that giant thing into the cartridge port here, let's just not enable it. So just a single wire is required there to add support for Master System games, and via the EverDrive that should work perfectly. So despite it looking alright with that piece of black vinyl there, it's going to bug the hell out of me. So from Console 5 I ordered 3 more of these glass. I'm going to give one of these away, perhaps at the end of the, well, I'll talk about it in the next video, and this mount here, because it would be nice to share the love, I guess, as Dennis said, pass this on. So yeah, I'll be giving away, let's say, a glass screen protector and one of those. You just need to buy, obviously, a replacement screen, which you can get for between £15 to £20. So I won't bore you with the teardown process, but I might just show you me removing the screen perhaps. I'm going to try and remove it in such a way, try and keep it so it can be reused. And what I'll do is, as I've peeled this protector off one of these replacements here, I'll stick it back over there and maybe do the same on the inside. Just try and keep that so that it could be used to, repair one that's completely, beyond, if you like. I might even just give that one away. If anybody wants that, I can give that away, because it is glass. It's glass. There's no marks on it other than just that little crack at the top left. So I've just pulled the thing out here and I'll just stick it on that bubble wrap, which has not had any contact with dust. It just came straight out of the packaging like that from Console 5. I'm just going to get a microfiber. I'm going to push this out with a microfiber. So I may well break this removing it, but in fact I'll try and push from the corner that's not cracked. So the crack's up there's a bit of dust on it, but I'm going to try and just carefully push from here. Can you hear it coming off? There we go. Just carefully. Yeah, there we go. You can see it's still in one piece. So as I say, I'm just going to carefully just, put this out of the way. So I've just sat that onto one of the other things there, just so that it doesn't get dust on the underside of the sticky bit. And then we'll just fit one of these, hopefully properly this time. Let's just flip that over and have a look at the cavity. Because can you see there were some bits of dust on the inside here, and that was bugging me as well. In fact, there's dust all over the shell here. It's picking up dust super easy, but I'll just clean the inside of that again with a cotton bud and some IPA. So as you can see, I've peeled the sticky back off, and then this time I'm going to pull this over here, see this little tab, pull it right up over there, like that, into the corner, so that we can actually lift it off as the final thing. So if we now stick that on, we should be good, I think. And this time, hopefully, get it spot on in the right position. You can see the buttons fell out then at that point. Well, you can see what's happened there. These are a f***ing nightmare to get in. It's actually bigger than the actual circumference there. So yeah, I'm not happy about that. It's a good job I ordered 3, isn't it? I don't know if you can see this. It's right up to the very edge here, and yeah, it's overhanging here. These protectors from console 5 are ever so slightly bigger than they need to be. Now you might be lucky, you might look out and get one that fits perfectly, but I'm having a real hard time trying to get this to fit without damaging the glass. I'll show you. I'll show you again. Let me just push it right down here. We get it right on the very edge. It's on the edge there. Press it down, and you can see there's a millimetre difference there. So you know, I don't know what you're supposed to do. Try and fit these without cracking the thing. Oh, God, I'm sure this one's going to crack again in a minute. Doesn't want to go in. It just doesn't want to go in at all. Well, I think I've managed it. That was extremely difficult. There's a big difference between the size of this one and the one that was originally on there, because there was just ever so slight, an ever so slight gap all the way around. Now there isn't. This is like super tight, and if anything, it's not quite down in this corner here as I would like. But you know, you're gonna break these if you just keep messing with it. What I tried to do is try and pull the screen like this here, and that's exactly how I managed to get it to go in, just a little bit. Pull it a little bit. It's as good as it's going to get, I think. Right, I managed to get it perfect in that corner, and the way I did it is I had to pull the case, you know, from the inside here and pull the screen the opposite way like that, and then it just snapped down. So that is super tight. And I would imagine that with an impact that would break pretty easily, but yeah, anyway, I don't plan on dropping it, so we'll just carefully, if we can, please let this come out here now. Hope it's not going to get trapped. Yeah, there we go. It's coming out. Oh, it's stuck on the inside of the edge there a little bit. Phew. Well, this is one of those moments that Vince was talking about on his videos, actually. If you watch my mate Vince, there was a watch he was looking at, and he tried to improve it and improve it and improve it to the point where it was far worse than when he started, and he wished to God he'd stopped at a certain point. And it's one of those, can you see, as I pulled that protector off, just look here, can you see that in the light? We've got some sticky stuff. I should have pulled the protector off before I stuck it on, because, you know, pulling it at an angle there, it's left some glue. I hope you can see that. So I'm now having to use a blooming IPA on a cotton bud here to try and get the blooming glue off the inside of the screen. I should have just left the other one on there with that little black thing, because so far I've destroyed one screen, which I am gutted about. I think that's come off. So just carefully now use the polishing cloth here, and hopefully I've not got anything stuck on there, or any dust particles or anything. So finally we have a decent piece of glass on there. Can you see that? Not a speck of dust on it, not a mark on it. It was incredibly difficult to fit. When this one broke, there was hardly any pressure at all. Because it's glass and because it's so thin, you know, you just need a little bit of an overhang on one side, and if you just try and push it in, this is what's going to happen. You know, you saw on the first one there, just chipped the edge. This one, yeah, the whole thing just completely shattered. So gutted, but they're quite cheap. You know, I ordered, I mean, well, I say quite cheap. I ordered 3, and it was, I think it was like £20 because of the postage from Console 5, you know, all the way from the States. But they're only about $3 or $4 each. So, you know, maybe I should have ordered more than 3. I would suggest if you're going to do one of these yourself, and it's the first time you've ever done one, order 2 or 3 or 4 of these. You can always sell the extra ones on eBay. And if you break one, you're going to know, you know, you'll get an instinct there after you've broken the first one of how fragile they are, and how important it is that you get it pressed, you know, onto one side or the other as far as it will go before you start to try and push it down. But it's not easy because it's sticky. You're trying not to touch the, you know, scratch it. You're trying not to touch the glass on either side. As I showed there, you need to remove the film on the inside before you stick it down, because if you peel it off like I did, you can get streaks of glue on the inside where it comes off at a funny angle. So yeah, not easy to fit, but I'm very, very pleased with the end result. So the way we've got it wired up to, pull the power in from here into the little DC to DC converter and drop the 5 volts from there and then backfeed the 5 volts to the board. It's a nice, efficient way of doing it. There's lots of different ways you could tackle this. You could just modify it so that 5 volts comes straight through here. But the reason I didn't want to do that, if I'm honest, is because it's super easy then to accidentally plug in, a Model 2 power supply, because they have got a slightly different size DC barrel, it's ever so subtly different versus the Model 1. But nevertheless, you could accidentally plug in, 9, 10 to 11, 12 volt type connector in there, and you've got a problem. Regulation is a nice thing to have. With a DC to DC converter, it goes up to about 40 odd volts, 48 volts or something, so it wouldn't matter too much whether if someone put the wrong connector in. We still got, because this is still wired the way it was originally, the diode is in there for the reverse polarity protection, so in theory there shouldn't be you shouldn't get a full circuit because of that diode. But it did cross my mind you could actually feed 5 volts in through some other connector, maybe a USB connector. And funnily enough, someone pointed out to me the day after I've done this, actually, it was yesterday I did this, that it's possible to do that, actually. I think it was, what's his name, Segaholic. On Segaholic's channel, I'll post a link down below, he stuck a USB connector, and I think the way he did it is the brightness pot down here, bear in mind we're not going to be using that now, it's an obvious candidate, it's an obvious place to put one of those little micro USB or mini USB. Just remove the pot there, stick the little connector here, and feed 5 volts in that way. You could do that as a secondary thing, so you've got 2 ways of power in this. But I don't like doing mods like that myself personally. I'd rather leave the pot on there, and I'll tell you why, because you never know, there may be other mods for this. Will might come out with a screen mod for this. I'm quite surprised that out of all these screen mods that have been produced for these different systems, I don't know why they haven't put an analog to digital converter on there, a very small one, and wired up to the pot here to adjust the brightness levels, because that's one thing I would do. It's potentially an idea, for people like Will and other people that are doing the screen mods for these. Consider that in future if you can. If you're using, I don't know whether it's possible to do it in the CPLD or something similar. You need some of the components and things on there, probably. But as I say, you never know, we might get a different screen for these in future, maybe an RGB one. The other reason I wanted to try and stay as near as possible to the original design of having, the 9 volts coming in and then the 5 volts generated from that 9 volts is to do with the battery pack here. And it says in the back here, DC 9 volts, 3.5 watts / AA battery, LR6 x 6. So, what's that going to give you? About 9 volts, isn't it, I think? So, 9 volts is going to come through here. So that's, something to consider. It's all very well having a USB connector, but what would happen if you had 9 volts here and then you had 5 volts through the USB at the same time? It probably would be okay, I would think, but I'd like to try and stick with the way it originally worked, of the 9 volts coming in from there or from here. I'm guessing this is going to go via the regulator as well. I'm not sure. I might just check that actually, because I'd be interested to see how these here are connected up with regards to the area around here. I think what's happening, I think these 2 connections here go to these 2 and they should pass straight through here. It's almost like a short, and this is marked EM9. I think this is just like an inductor. It might have some caps or something built in as well, but it's like just a little package that just passes the connections through but filters them, and then they go to the 2 connections there. So then the first connection is ground, and then the second one is the 9 volts, and I think the 9 volts probably connects to the point where the regulator goes up here actually, but they're missing on here, so I can't really trace further without taking the board out. But these do seem to connect up to the regulator, so in theory if I had a battery pack now, that should work just the same, I think. So we didn't cover all the chips in the previous video. So that's a Sony CXA 1645M, so that's the video encoder. The quad flat pack here, I am guessing, is the LCD driver actually. This is what's driving the rows and columns and things, in order to display on the LCD. This chip here, I'm going to look this up in a minute. I am honestly not sure what this is doing, actually. And there's also this area here, which I never thought of until now. You know, inspected that super close. There's a 4-digit part number on there. I can't tell what on earth that is. Due to the number of pins and the fact that you've got, I think there's a little connector over here, you can't quite see it, just up there. Yeah, hopefully you can see it a bit better. I think that goes to the inverter, actually. So I'm guessing that this area here is perhaps some sort of DC to DC, like step up. And there's a, can you see that beefy resistor there, R202? Is that like a shunt or something? So I'm thinking that this here might actually be used to feed the connector there for the high voltage side. I could be wrong. Could be wrong. I mean, I could measure around that on my meter to see what we've got around there. But I'm just guessing that that's what perhaps that is. Now, and down here, now there's an awful lot of connections on this, but I think that this is the audio op amp. It might do something else as well, because there's an awful lot of connections for nothing but an amplifier, but it is right next to the audio section here. I can't imagine what else that would be doing, actually. Back over to this board. There's a RAM chip here that I don't think I mentioned. You can just about see that. It's an Oki chip there. You can just about see the part number. On first inspection, you could think, oh, that's going to be for the Z80. It's not. If you follow the traces, they go through these little resistor arrays here, and the traces go up here, across to here. So I think this is the VRAM, actually. And if you flip over the smaller chip here, which is kind of underneath here, which you might think is going to be VRAM. It's not big enough, really, but you know, it would be more logical to have these the other way around. You would think that that is related to the chip here, maybe for the VDP, you know, the graphics RAM, but it isn't. There's some of the traces, they come down here and they go they come down to the points here, so you can't quite see, that's not focusing, and come up underneath the Z80. So that is the RAM there for the Z80. The one over here, the larger, again a larger one, is probably almost identical in size to that one there. It might not be. It might be twice as big, I'm not sure. That is obviously straight under the CPU there. That's the work RAM. So I'll show you on this cap over here. You need to get the... So I'll show you on this cap over here. You want the cutters as low as possible, like that. Hold, press down like that, and clip into it carefully. So as I say, you know, you do risk some damage. You can see you're left with this piece on here like this. Sometimes, if you lower down, you won't necessarily have to squash the can, but in my case, I'm going to have to just squash it just a little bit in order that I can then just pull off the bit that's left, and hopefully you should be able to see this. But nevertheless, there is a risk in doing it this way. You can see that bit just pulled off there, it's crumbling. And as I say, the lower down you go, the easier that will be. And you get the little black piece of plastic here, can you see? And it kind of crumbles that. There you go, it's come off. It's come into 2 pieces, look. Get that off. So, yeah, there is a risk of doing it that way. But, as you'll see, all you're left with is the contacts. You know, if you just heat those up. Yeah, you can see one of the contacts just came off there, no worries. And let's try and get that one out of the way. And that one's off as well. So no pad damage there at all. We'll clean up with some IPA and flux, but that's the technique you can use if you've not got hot air. But as I say, there is a risk. You know, like I say, if one of the pads was corroded, maybe 50% chance one of them will come off when you do that. But if you're super careful, you can probably get most of them off that way without an issue. But I'll also show you the proper way with hot air on the others. So I just had a little bit of chip quick flux there. As you can see, we just heat with the solder braid. And the pads are coming up nicely, actually. The one on the right there, that's the ground, you know, and I can tell it'd be super easy to attach the solder braid if you're not careful. You know, if you just pull the iron away and leave the solder braid, it'll stick to it because it's connected to all this area here. This will absorb an awful lot of heat, so, you know, one side's going to be easier to do than the other. Now, because there were obviously some risk that some electrolyte could have got on there, I will clean these up, you know, and then inspect, and then add some fresh flux before we try and fit the new cap. So a big shout out to the Console 5 wiki, actually, and that's the place where the cap kit came from that Dennis provided me with here. So again, I'll post some links down below, but you can see they've got a guide here on which capacitors, you know, what sizes. So the one I've just done is CE206, which is 22 microfarad, 6 volts, not 16 volts, yeah, CE206, 22 6 volts. So a close-up here, you can see there's a little bit of solder still on here, but I'm not too worried about that. But what I want to show you, can you see the silhouette, the outline here of the component? You've got like some angled bits here. You've got the positive on this side's going to be the negative. And if you look at the cap, I don't know whether you can see the little corner sheared off there, and this one is square. So, you know, that can assist you getting one of these in position, but bear in mind you've got to, you know, assume hopefully that the cap is been manufactured correctly, but generally they all are. So yeah, you've got a square edge there and let's say an angled bit here. So we know that it would go, you know, in that position there, and this is the negative. The black band is the negative. So you just got to align it, get it in position, hold it down. Typically I'll use a tool like this, you know, press it like that and solder one side with a little bit of flux. Add the flux first, you know, so hold it down and then just solder one side and then the other. So I know that's slightly out of focus there. That's about the best I can do. So I'm going to get some solder onto the tip of the iron here. I'm going to get a crazy amount. I haven't added flux yet to this point here, but I just want to try and, if we can, just get a bit of solder on there. We'll just see if we can flow that point. Bear in mind this is the ground side, so this side is going to be super fiddly, certainly without flux. Yeah, that side's on, so that might look a mess. Let me just do the other side off camera. So on the other side, and I appreciate you can't see that, I've just added a little bit of flux there, and I'm going to add the solder at the same time, and that should make that side super easy to flow. And I can show you the result of that in a minute. But what we can do now on this side is add a little bit of flux. Clean the tip, add a little bit more solder to the iron here. Again, I'm sorry that's not focusing very well, but we'll just reflow that now with the flux in place, and hopefully we should get a nice clean solder point there. As I say, because this side's ground, it's absorbing tons and tons and tons of heat there. Yeah, so I would suggest that one is a difficult one to do. That's probably the most difficult one I've had so far on this board. All the others have been really easy because, like I said, the cap they provided in the Console 5 kit is quite large. It could do with being a millimetre or so smaller, really. But if we just clean off the flux, and I'll just give you a close-up so you can see, we do have a connection on each side, but it is very, 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 very close on each side. It's right up to the very edges of the pad. There's very little room around that, which can make that one quite difficult, especially with the ground side absorbing so much blooming heat. So you're on macro, and can you see there's a tiny bit there on that area. This side was a bit easier, but again you can see, you know, we've got a nice little solder point there joining that up. I've put a red dot on it just so I know I've done that one, so these all down here are okay. That one's been done. We just need to find some more. Yeah, so I mean, look at that one. Can you see the top of that? It's kind of like being deformed. It's had some impact damage or something, that cap. So I'll perhaps do that one next, I think. We use hot air to remove that one. I've set the hot air to about 350. I've took it down. When I've been removing chips on Neo Geos and things, 400 to 450 is what you're aiming for. But on something like this, you know, these are super small. It's not going to be. It's not going to need too much heat. I might need more heat to remove the one we just removed a minute ago. You know, the one we cut off. But this one here, I think we're going to be able to get away with 350. So, and it's not going to need long. It's not going to need long at all. Just needs to just you know, go from side to side here, each side up, and then at some point it will just become loose, where it'll just, you know, you'll feel it move. It'll come off dead easy. Also, bear in mind, if you're using heat next to plastic connectors like that, get some foil over that and some cap and tape it down. But I'm not too close to it, so I think we'll be okay. Sometimes heating the cap can itself can actually help the process as well, not just the solder points there. There we go. So some people use hot air to actually install these, but I wouldn't do that, and I'll tell you why. Because you're exposing the cap to additional heat. You know, if you just hold it down and just heat one side at a time. So just get a bit of solder. Yeah, as I say, if you don't use hot air to fit it, if you just hold it down with some pressure, just crazy amount of solder on one side until you get a join, then like say you can add some flux on later and reflow it. You can see that's on there now. And there you go, with a little bit of flux, you can see that looks super tidy. So before I just whiz through these and replace them all off camera, you know, the remaining ones, I'll show you the third technique of lifting. So again, you know, the risks with this, I would say, is probably more risk actually of damaging a pad by trying to gradually lift one side and then the other, and certainly very high risk if it's corroded. If it's corroded, you literally will pull one of the pads off one side by doing the lifting technique. But the first thing to do is remove as much of the solder from that side as you can, just using some flux and desolder braid. And then what you want to do is, you know, heat that pad and just gently, if you can. It doesn't help that I've picked the side with ground on here actually. You're probably better off trying this on the other side first. Let's just alternate to the other side. So we'll try that again from this side. As I say, I'll heat the point where the cap joins the board and just carefully try and lift it. Yeah, can you see that? It's just lifted on one side, just a little bit. So then you could alternate to the other side and do the same thing over this side. Heat it, I can feel it moving, look, it's come off already. There you go, it's come off. As you can see, we've got no damage there, but there is a higher risk doing it that way. Personally, if you've not got hot air, I would cut into the cap carefully. But as you can see, we didn't damage it. We haven't damaged any of, you know, doing the three different techniques there. We haven't damaged it either way. Now here's a good example of one that I've took off. I've cut this. Can you see? And can you see this powder here? This is electrolyte. This one had been leaking. So they can look okay sometimes, but they're not. So yeah, that one definitely needed swapping actually. You know, you can see the crustiness here. This is all electrolyte around here. So a quick update. I'm losing the will to live doing this. I really am. So you can see I've done quite a few actually. There's most of them done. We've got 2 here to do still. 1 here. I think, is that right? Just the 3? Yeah, because I've been marking the tops of these. Yeah, 1, 2, 3. Yeah, just three more to go, and then we can reassemble it. Hooray! Thank goodness for that. That's took about 2 hours in total, but as you can see, I have replaced every capacitor on that now. The polymer one I haven't done underneath. I don't think it needs swapping. I've always got that as a spare. You can see actually it's got a purple band on there that indicates that's a polymer in the kit there. So I could always swap that out at a later date, but I don't think it needs swapping out actually. But I am happy I've replaced all of those, because 1 or 2 of them, you know, they had like crustiness underneath, like a dry powdery sort of stuff, as if at some point they had leaked. So reassemble and test now, I think. So I know Dennis has done the Master System mod to his before, but it is something I've looked at many years ago when I first looked at the Genesis. I was trying to understand how the backwards compatibility worked, and there's a pin, I think it's the M3 pin on this ASIC. M3 comes from where is it now? Pin 45, which is going to be somewhere up here on this side here, and it needs to go to I forget which pin number it is, but it's the M3 pin on here. It's active low. I believe it's the 3rd. I can't remember. It's the 3rd from this side or the 3rd from that side. I think it's the 3rd on the top row there. I'll confirm that in a minute. But yeah, we need a wire from there to, as I say, pin 45 on this ASIC. It's just a question of how I route it, actually. So in order to do the soldering, I think what I'll probably do, because it's so fine pitch, that is overlap some Captain tape over on both sides and just try and leave that single pin exposed, because I don't think there's any wires or anything that go to it. It's probably just not connected to anything. I've just confirmed the cart pin out, B30. It's here, so it's not up here. It's here, the 3rd one on the bottom row. Which causes a bit of a problem because it's on the inside there, so you can't really easily solder. If it was on the outer pins, it would have been a bit easier. I'll start the wire from here, I think, and then just try and work out the best way to route it. So we'll solder this point first, just get a bit of solder containing flux onto that single pin, and we'll just connect that up there. That's it. So I've fed the wire through the hole there. That's about the nearest point, I think. We just need to join it up to pin 45, and as I say, I'm going to use a bit of Captain tape, I think, just try and isolate the pins that I don't want to solder onto. So if there was more space here, perhaps I wouldn't mask this off, but I'm just trying to protect myself here. Can you see that little white dot? That's 45. You count backwards, you know, you've got 51, 50, 49, blah, 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 and you get to 45 there on that white dot. So let's see if we can stabilise the camera a bit. Yeah, that's not too bad. So you can see I've just left that one pin exposed. It should just make it a little bit easier, because I don't want to risk it, because we're in a confined area around here as well. It's going to be a bit fiddly trying to solder a wire onto that. But I think I can just about do that now. Stretch this Kino over here, get it the right length, and then just solder it onto that. And as you can see, I've just about managed that. So I just need to just carefully pull the Captain tape off here now. And we can reassemble that and go and give that a try. And there we go, all reassembled with new proper glass. Let's go give this a try. Yeah, so as you can see, Master System games are working fine. Sweet. I'll connect it back up to the TV as well, just to show you, you can play these Master System games on the TV as well as the Mega Drive. Yeah, so I don't know whether you can see, you get the jail bars there. I can see, I don't know if you can see, like little lines down there. So it's the typical thing you get with the Mega Drive, it's just the same here, so I'll start again. But nevertheless, it's brilliant being able to play Master System games on the move as well, especially via the EverDrive. Sweet. The one downside is it does display on the screen at the same time as the TV out, so you're kind of wasting battery power if you're powering it by batteries that way. So I'm trying to hold it stable there on a super close-up. Can you see the lines I'm talking about? The last few videos where I've said you get these lines. I think that is noise from the DC to DC converter, but you don't see that on the TV. As you can see from that close-up, it's absolutely rock solid. So it's not as if the DC to DC converter is introducing some noise into the video side of things on the Nomad here, on the Sega chipset there. It is just the LCD screen. It could be it could just be the quality of the LCD screen, but I think not. I think it's the DC to DC converter introducing some noise on the little PCB that goes to the screen there. So someone with the right equipment, I'm thinking maybe a Voltar or somebody like that. If you've got a spectrum analyzer, you could work out what frequency that noise is there. Even on a decent scope, a digital scope, you could capture that perhaps. If you zoom right in and find those tiny little pulses there, you could work out what that is. It's going to be something in the region of kilohertz, 100 kilohertz or something like that, I would think. You could add a cap, an inductor to optimise that. So yeah, I'm just floating this out there for the more professional channels to have a look at, because we could get this really super perfect by filtering out that noise. I'm pretty sure that's what it is. So just some final things wrapping up here. I thought it'd be a good idea to test the connections underneath, the battery connections. I've measured whilst this is powered, voltage across there's nothing. So obviously it's isolated, so you can't destroy your batteries. Or recharge your batteries either, that way. So if we just measure on the meter here. So we're looking at, this is the Model 2 power supply I've been using, and this is why in part 1 I was saying between 9 and 12ish, because just look at this, and I did mention it could be higher. Look at that, just look at that, 13.58 volts. So yeah, there's no load on there, but this is why when they say, oh, it's like 9 volt in, yeah, the power supply says 9 volt, but you're looking at between 9 and 14 volts, as you can see. This is the whole reason why you've got the regulator and stuff on there, but now obviously we're using the DC to DC switching. So the next thing I'll do, now I know the outside is the ground, I'm going to measure connectivity here just to see which one of these is the ground, and temporarily just feed 9 volts in there just to make sure it's working okay with the battery contacts. So I've set that a little bit lower than 9 volts actually, there's about 8 volts there. So just to confirm which one of these is the ground, what we need to do is the ground contact is the flat bit, not the pin. I can't see which way up it is, I think it's on the bottom there. So if I test on continuity, you can see we've got a connection there to the bottom one, but that's not the centre pin. If I test on the centre pin, you'll see we've got no connection to either. So that's correct. So that just tells us that's ground, that's 9 volts. So yeah, it's not going to be easy to power this. I might just put my Turtles cart in so that it boots with that particular game. Hang on. Nada. Let's try that again, just in case I had a bad connection there. So we're on exactly 9 volts now, because I didn't seem to be doing anything there, actually. So ground on the bottom. So in order to work out what's going on with the battery circuit there, I'm going to take this out of its shell. We'll connect up the bench power supply with some croc clips here, and I'm going to measure the round because I know the voltage should come out on one of the 2 pins here, the 9 volts, and then I'm just going to trace it. I'm guessing we might just measure it somewhere up around here, and I'm guessing it's probably because that regulator is missing there, that we've got a missing connection, but there could be some of the faults on the way. So that's the ground connection on the battery there, and it goes up to one of the wires on here. It comes out on the second from right pin on the black connector here. So we've got connectivity coming through to that point, and on the other side, the positive, that comes out from the end connection, and that goes to the wire next to it. So we've got 2 wires there. I'm guessing because we're up here, it's going to be something to do with the damage around there. The interesting thing is, the ground's not even connected. You know, if I measure from the ground one again down here to, I don't know, one of the wires, not the wires, but they are wires, I think, that's got solder on for the ground here. See, there's nothing. So it's like we've not got, I think we've got a ground, where else is a ground on here? Yeah, that's going to be ground. Yeah, there's no ground connection, and there's no 9 volt connection for the battery. But we do end up on the 2 wires there. Now it could be something to do with this little chip here. I wonder if this is designed to charge the battery pack. Maybe we've got a problem in this area here, but I would at least expect one of these to be connected somewhere, maybe the ground. So I will need to take the board out super carefully, unfortunately, just to have a look on the underside to see what's going on with the wires at that point. Yeah, I've confirmed what's going on here. That right hand wire there, that is the plus 12, and I've just traced it does go to the centre point of this switch, so the plus 12's okay, the ground isn't. The one to the left here, the left hand wire, that comes up, I think, on the underside and works its way to one of the wires here, probably this one, and because there's a piece of trace missing here, that's not joined up, so that's why there's no ground connection. That's why the battery bay is not doing anything. So I just need a super short wire from this wire here to well, somewhere on the ground. I just want to just double check to make sure where it should go. I'll follow on the underside first to see where it comes up here, just to make sure I'm not going to connect it to the wrong place, but that's all it needs, just one bodge wire, and then the battery bay should work. So I believe the problem is the DC barrel socket here, you know, the jack. Because if I measure from the, where's it gone now, the wire, so I've got the red on the wire there to the left of the socket here, you can see we've got short. Now, interestingly, the ground is connected to the other side for the DC input, you know, from the jack, which says to me that this is switched. The ground toggles between that side and that side. I think. So I need to carefully remove the DC jack, inspect it, and just see if I can straighten up whatever damage has occurred there, because I think perhaps when I raise the spade to make a, you know, the spade type, it's like a flat edge connector inside to make a good connection with the ground. It's perhaps not going, it's not touching the opposite side when the thing's not in, you know, when it's at the top, it's not touching the side that would enable the battery ground connection. So I taped a piece of paper just over there, actually, just to protect that, and you can see I've removed the socket here. Yeah, so the problem is the flat spade bit, you know, when you push the jack in. Let me just see if you can see this. When you push it in, yeah, let me see if I can show you this. When you push the flat thing in, can you see a bit going up and down in the back there? And there seems to be like a little contact on top of it that's maybe designed to short to this one here when there's nothing plugged in and it separates. But when it's out like that now, it's not joined. So I've ordered a new power jack. In the meantime, I've took it from this faulty Mega Drive Model 2 actually. I think this is just a clean-up job again. I think this will be working, but it's interesting just looking at this. You can see it's got the same subcode on the bottom there, FC1004, and you can see it's a single ASIC version again. So yeah, they are interchangeable actually. You can take one of these to fix a Nomad by the looks of things. And if you look at the RAMs here, they're the same physical size RAM chips that you saw on the board there before. So and I think it's pretty much got almost the same chips. Yeah, I think it has. I think if you look at the chip down here, yeah, that's the same RAM that was used for the Z80, I think. The only thing that's different with this is it's not got the combined audio amplifier. You know, the audio amplifier chip was quite a large, I'll perhaps see if I can show you on the board in a minute, it's got a lot of pins on it. You've got individual op amps on here for merging the PSG and the FM and whatever channels and things there. It's a subtly different on the Nomad, but you've probably got the same video encoder there, or if not, in fact it's a different video encoder, but yeah, it's interesting how this is a slightly different revision to that board I showed previously on my channel. It's got the same capacitor array here, but it's differently assembled. Can you see it's got like a ceramic top to it or something? Very interesting. I will need to clean this area in a minute because obviously I've got solder on that little cap there. It's going to need just cleaning up in general. But I'll show you that we should have yeah, that pad on that side's not great. Just from the person that previously removed this before it got to Dennis. As I say, Dennis didn't do this, and incidentally Dennis didn't remove any of the caps and do any of the damage either. It was already like that. He hadn't actually done anything with it since it arrived. Came to him in the state. It's arrived to me actually. So we'll clean up around there, reattach the wires, and we'll test that. But the main thing is, if I just show you with the meter now, continuity, what you should get on one of these, just listen, both those pins are joined. That's right. As soon as you plug the jack in, it'll be separated, and I think only then that one is connected as a ground. Now, the interesting thing there, that does cause me something I need to think about. The ground, I think I had connected to, which side was it? Was it this side? Yeah, you need to make sure you connect your ground to the side that's always connected, regardless of whether the jack is plugged in down there, if that makes sense. But the 12 volt coming from the cap position up here was correct. That's okay, because that's the way it seems to be routed with the batteries, with the battery contacts. I think while I'm on this side of the board, I'm going to replace the one cap I haven't yet replaced. The legs look a bit black on it, so maybe that has leaked or something at some point. This is a polymer type capacitor. Just looking where the negative, if the negative's to the bottom there, and it is kind of just like bodgily mounted. This is like a factory mod, presumably. So if we just heat both of the legs at the same time, there we go, you can see that's removed. So a replacement polymer cap is on there, and I've put a little bit of Captain tape just underneath. I don't think the can is conductive, it's kind of like a silver paint, but I don't want to take a risk, but as you can see that looks okay. So there we go, and just for reference, because I'm getting towards the end of these videos here, the right hand side of the cap there, that's the 5 volts. That's where you put the 5 volts from the DC to DC converter on the screen. The 12 volts comes, there's a cap here. The positive side of that cap is there, and that's the switched positive of the, you know, the 9 to 12 volts that comes in, and the ground goes to this side here, which is the always connected ground, if that makes sense. So for example, when you plug the power supply in, it'll disconnect the left pin here, which is the battery ground, but as long as there's no power supply in, the left pin is joined to that pin, and we'll just confirm that. So as I say, when you've got no power supply in, the two in theory should be joined. So let's now test it with the bench power supply again on the battery connections, and we should have a connection here to the ground now, hopefully. Yeah, so we've now got a connection there. So if you test one of these, that's a good check to do. If you want to test that DC jack, you know, obviously you can test the connectivity of the DC jack anyway from one side of the ground to the other, but if you've not got a ground there, you know that the switch inside of the DC jack is faulty. So that's the ground, that's the 9 volts. And the nice thing with that, with this meter here, this is now working, it's in demo mode. I can switch it into amps and we can see exactly what's being drawn there. So I'd be interested, if you've got a Nomad, how much current do these draw with a normal screen? Because we're less than half an amp there. That's really, really good actually, about 0.4 something of an amp. So with a decent battery you could get quite a lot of hours use out of that, I would suspect. So I'll try and show you what I was trying to show you before. There you go, can you see that? That's just powering the battery. Contacts on the back there. So yeah, I'm sorry the screen is at a really weird angle, it's the best I can do. But yeah, battery bay contacts are working. So one final thing, you might have been feeling a bit sorry for the old Mega Drive 2 here, or Genesis, you know, the fact that I've borrowed the socket off this while the other one comes in the post. But look at the way this is wired. They've used a switched socket here, but the grounds are just joined together. So this socket does work okay, it makes a really good reliable connection. It's just a case of the switched side of it was not working. But the fact these are joined together anyway, it doesn't matter. So actually there's nothing lost. I don't even need to swap the socket out on this when the new one arrives. So I'm just going to fit that on there. We'll have a look at this Mega Drive in a following video. So it's a shame the Titan Overdrive 2 demo doesn't work actually, and the reason being is I think it's been coded to a compile machines. The original Titan Overdrive demo you can see here, this was obviously developed to work on either PAL or NTSC, I think. Sweet. Anyway, I do hope you found the video interesting. Please like, share and subscribe, and I'll catch you in the next video. Special thanks to Dennis Vandenbroek. I am blown away. He's a really nice guy.